This is the
right?
current
And
version.
this is the current value. We're looking at the way waves and the movement of water on the continental shelf interacts with those sands on the bottom of the shelf. Chemical reactions are occurring within the sands, within the water that seeps down into the sand. And when that happens naturally, one of the things that occurs is CO2 is neutralized. In other words, there's a natural process that removes CO2 from entering the ocean. So here we're measuring a quantity in water that we collect from these sands called alkalinity. Alkalinity is well known to people who maybe drink fancy water, but it's a very common property of seawater, and it contains information about what the CO2 in seawater is doing, how it is partitioning within the ocean water. So the water that we collect from the sand in the bottom of the ocean, we measure the total amount of CO2 in that sample by putting the water into this glass vessel, adding some acid. That turns all the carbon species in that water into CO2. And then on this device, the needle goes into, it's pumping gas into that sample and is moving all that CO2 out of that sample. This box over here feeds the gas into this big box right here. And in this box, a laser is shining a light in a chamber that's full of CO2 gas. And it's telling us how much CO2 is in that sample, and it's also telling us something about the CO2. CO2 has a signature, and it's called an isotope. There's carbon 12 and there's carbon 13, and this machine can tell us how much 12 and how much 13 is in the total CO2. And that's a signature of how that CO2 got there.